Flip Classroom video for WJC A-Level Mathematics Unit 3 Pure M2.3.7 F1 First order differential equations, variable separable or separable first order differential equations. So first order differential equation, you formed first order differential equations in your differentiation section. Anything to do with the rate of change, remember that differential notation is a rate of change, hence we'll get these differential equations, and a first order is simply because it's got a dy by dx any rather than a d2y or an f double dash or even an f triple dash, whatever you want to deal with. So as I say, you formed simple differential equations, now you just simply need to be able to solve them. And the technique is to collect usually your y terms on the left hand side and your x terms on the right hand side. Not worrying too much about constants because we can integrate those beasties. And you can do it that way. So if I give you the first order differential equation, dy by dx equals 2xy squared, and you notice the square only refers to the y term. If I rearrange that, I'll have 1 over y squared, or y to the minus 2 dy by dx equals 2x. Now, if I integrate both sides with respect to x, you notice that y to the minus 2 dy by dx is the result of implicitly differentiating something. Okay, so it is the result of implicitly differentiating something over y to the minus 1. I'm not saying exactly what it is at the moment, but that dy by dx to my mind should really stay there to be precise. So I've got, and as long as I'm integrating both sides with respect to x, it's perfectly reasonable if you think about all your mathematical knowledge. As long as you do the same throughout an equation system, that's perfectly allowable. So therefore, the integral of y to the minus 2 dy by dx is minus y to the minus 1. And the integral of 2x, that's why I left the 2 inside there, of course is just x squared. I'll notice that straight away. Notice I've put my constant in. And it's usual in these particular questions, or these types of questions, to, when you're looking for a general solution, that is where it's got a constant term, to actually put it in terms of y equals rather than the minus y to the minus 1, which I've got. So that minus y to the minus 1 is minus 1 over y. So therefore I want it to become a y. I've got to reciprocate that side, so I'll have to reciprocate the 1 over x squared, or the x squared plus k, which will become 1 over x squared plus k. But I've got to deal with the negative sign as well, because I've still got that negative sign there. So if I personally would write it that way, 1 over c minus x squared. Now I've simply said that c equals minus k. In this case I haven't written it, but it's just a constant. You notice that what I've done is I've changed the signs all the way through. In other words, y to the minus 1 is equal to minus x squared minus k, which is untidy. Minus k is just a constant, so replace it with a c, so therefore minus x squared plus c. Then I've reciprocated in effect. Now there is an alternative method, which is the one you're most likely to see, and certainly it's the one you'll see on mark schemes. I personally think it's mathematically incorrect, but never mind. So this is a common approach. If I take that y to the minus 2 dy by dx equals 2 to the x and split up the dy by dx, it's not a fraction, it's a rate of change of y with respect to x, but to all intents and purposes you can treat this as a fraction. I would get y to the minus 2 dy is equal to 2x dx. Now the common approach, if mathematically incorrect, but it works, is that you integrate the left hand side with respect to y and the right hand side with respect to x. It works, but I say it through gritted teeth. So therefore I get the integral of y to the minus 2 dy is equal to the integral of 2x dx minus 1 y to the minus 1 is equal to x squared plus k, which takes me back to there. So it's exactly the same approach. It's an easier integration, albeit, if I was going for an interview at a top university, it's not one I would choose to use. I'd choose to show the way I was showing it. Particular solution, this is where you have got initial conditions or a set of conditions that link your variables, and you can actually evaluate the constant. So it's just a step further. So if I give you this particular differential equation, x divided by dx equals 1 over cos y, and of course that 1 over cos could be written in a different format as sec y, and I gave you that x equals 1 when y equals 3 pi by 4. So if I rearrange this, get my y's on one side, my cos y, multiply both sides by cos y, it removes it from the bottom of that fraction, and I divide both sides by x, I will get the integral of cos y dy by dx with respect to x. You notice I'm sticking with what I prefer. I'm not going to go write the alternative for you. You can do that yourself. Is equal to the integral of 1 over x with respect to x, and now the right hand side's a dead easy integration, left hand side a dead easy integration. Integral of cos, of course, is sine, so therefore the integral of cos y dy by dx is just sine y. Sine y equals ln mod x plus a constant. Notice I've introduced my constant, and now I use my values of x and y that I was given. Sine 3 pi by 4 is equal to ln 1 plus k, but ln 1 of course is 0, and the sine of 3 pi by 4 is either 1 over root 2 or root 2 over 2 if you prefer it that way. So therefore root 2 over 2 is equal to k. Easy peasy lemon squeezy. So my final solution, which is the particular solution in this particular case, because it is dependent on those particular pair of initial values or values that you're given, sine y is equal to ln x plus root 2 over 2 or something equivalent. Now I also use an alternate version to this, and that is where I use x and y as variables, and I use my initial conditions or my given conditions as the lower limits. So the integration is just the same. The integral of cos y dy by dx with respect to x is simply sine y, but it's now between the limits y and 3 pi by 4. My integral of 1 over x between the limits x and 1 is ln x between x and 1. So I happily get that, and then if I apply my limits, I'll get sine y minus sine 3 pi by 4 is equal to ln mod x minus ln 1. Well, of course ln 1 is 0. Sine of 3 pi by 4 is root 2 over 2 as I had before, so I'll get sine y minus root 2 over 2 equals ln x, which gives me exactly the same solution as I had before. So you can use either of those, it doesn't make any difference.